Hey, this is Suey778 coming at you again, and today on the table I got a brand new meter to show. This is the new, well, relatively new Aneng Q10. This was released, I believe, in the fourth quarter of last year. I got this from Banggood for about 32, 33 bucks. Currently it is available for around 35, maybe a little bit less. I have seen it on Banggood and AliExpress. So without further ado, let's take a look and see what we get in the box. So, we get some leads. Temperature probe. Get a nice little carry bag for this thing. And a user manual. And a pretty nice one. Here's some of the specs for you if you want to take a look at that. Okay. And last but not least, we get the meter itself. If I can get it out of there. And there you go, the Aneng Q10. Pretty nice looking meter. And let's go over the features. Okay, first up we're going to peel the virgin covering, if I can get it out of there. Come on, there we go. Oh, okay, beautiful. All right. Okay, we got one more sticker to remove here actually. This thing down here that says stop testing voltage on current mode. It's got the current jacks covered up, so we need to tear that off before use. So let's go ahead and do that now. Let's see if we can get it off. There we go. Well, I don't like what this sticker is doing. It's kind of leaving a mess. Hopefully I can get all that off of there. Okay, there we go. Now it looks all nice and pretty. Okay, now that we've got everything peeled off, let's go ahead and show you the features of the meter. It's got a nice dual display here. That is a reverse LCD, not quite white and not quite sky blue, kind of in the middle somewhere. You've got your select and mode select and VFC buttons, your range and rel, max and minimum, and your hold, which is a freeze frame, and a long press will give you a flashlight. Long press will give you a relative here. On the rotary selector, we've got our voltage, VFC, hertz, duty cycle. Next up, we've got millivolts, hertz, duty cycle, and temperature. Then you get your resistance, continuity, capacitance, and diodes. Then you get your non-contact voltage here. Square wave output here, up to 5 kilohertz, I believe. Then you have amps, milliamps, and microamps for your current. Here's your common jack right here. Most of the functions, you know, for voltage, diodes, resistance, frequency, and square wave output, and temperature all go here. Then of course you've got your current jacks, you've got your fused 10 amp max up here, and then down here you've got a 200 milliamp. It's actually milliamp and microamp jack up to, says 200 milliamps maximum. This is rated as a category 3, category 2, 600 volts category 3. This is basically just another 250 volt category 2, and that's all it is. This has minimal protection. We will show that later. Let me go ahead and show the turn it on. Let's show the dual display here. And there's your hertz up top. Actually, you get 3 decimals up there, which is nice. And then, of course, if you hit it again, it'll take you to hertz in the big display, and then your duty cycle in the small display. As you see, yeah, it actually performed for me. I don't know. I guess it picked something up there. Of course, up here you get your millivolts, and this, of course, the select button will take you to Again, your hertz, duty cycle, and hertz. And then there is your thermometer. All right, and then of course you get your resistance, continuity, and diodes on the same function. And then your capacitance. Then you have your non-contact voltage. Then you got your square wave output. And then of course your current. And this thing actually likes to beep. And this does have an auto off function. I think after 15 minutes you can disable that, I believe, by holding down one of the buttons. I think it's the select button. And as you can see, this beeps at you when your current goes down to 0. Okay, anyway, now let's get that off of that. I don't want to listen to that all day. This has 9,999 counts, so it's got a fairly decent resolution on its display. The manual, again, is in a legible font and a nice little kind of leaflet, little magazine style kind of laminated paper thing, so nice job on the manual. And again, like I said, the protection, it is what it is. I wouldn't recommend this for anything other than, low voltage bench work for electronic hobbyist or what have you. All right, I'm going to show you the battery compartment, and then we're going to go ahead and take this thing apart, and we'll see what we find inside. Okay, so there's a screw here for the battery compartment. I'm going to go ahead and take that out real quick just to show you what we got. This does take 3 AAA batteries. They are not supplied. I've already put some inner loops in here. A little bit tricky to get this out of here. Maybe I didn't unscrew it the whole way. Yeah, got it. There we go. So you have to kind of lift it up and it all comes off. As you see, 3 AAA batteries. It does have a metal insert here for this screw, so that's a good thing. All right, I'm going to take this apart real quick, and then we're going to show you the innards of this guy. Okay, so I've got this taken apart. First thing I want to show you is this. Happy to report that on the back of the unit here, the battery compartment is completely contained here. It's no longer on the PC board like you see on a lot of the older Anengs. And here is the PC board. And the first thing that pops out to me is this big, long current shunt. I mean, for such a small unit, yeah, runs all the way, it's a pretty good size shunt. Glad to see that in there. Got your ceramic fuses here and here. I think this is the 10 amp and this is the 200 milliamp. Your input jacks are of the split variety. They seem pretty well solidly built and secured in there. And as far as your other protection goes, let's see, you've got some resistors here and here. Looks like some more up here. And then you've got a single PTC right here. And what appears to be some diodes and some other stuff up in here. This looks like your main processor. I can't read what kind of processor that is. Maybe the camera will capture it. Let me put it up real close and hopefully it'll focus. But that's your main processor there, your speaker. There's your NCV antenna. Not much of a going concern. And also looks like the LCD driver is right here. Flashlight diode is here. Not much else to say about it. Fairly Spartan design, I would say. Not a whole lot of protection here, though. I would most definitely say that, I'll give you a sideways view of it. If I can hold my hand still. Not much to say about the protection. This is definitely, meant for low voltage electronic hobbyist use. I would not use this multimeter for anything, above 30 volts. Maybe to check an AC outlet, that would be about it. But there you have it. Let's go ahead and put this back together and let's do some tests. Okay, first up is going to be the DC voltage test. I'm going to be running this with my Rockseed RS310P as usual. We're going to start off at 2.5 volts, so let's go ahead and engage this and let's see what we get. Okay, we're getting 2.503. All right, let's go to 5. 5.003. All right. Let's go to, no, 5.005. All right. Let's go to 7.5. And you're getting 7.504. Pretty close. 10 volts. And we're getting 10.00. Okay, yeah, pretty much right on the money there. And let's go ahead and jump up to 32 volts. Let's see what happens. And we are getting exactly 32 volts, looks like. Yeah, wavering a little bit there between 0 and 2 and 1. But, all right. So I would say on the voltage, DC voltage test, pretty good. Okay, let's go ahead and do the AC voltage test. I'm just going to test a power outlet here, and then we'll get a quick look at the hertz and the duty cycle while we're at it using my probe masters. Generally speaking, we'll be using probe masters for most of these tests, but we'll notify. Let's go ahead and put these in the jacks here and see what we get. Okay, and currently I'm reading 121.5, 121.6. I do like that second decimal there on the hertz reading. Let me hold that in there. Let's switch over to hertz and duty cycle. Okay, and as you can see there, the bar graph is showing. I say very little about bar graphs in these kind of meters just simply because they don't do anything except follow the speed of the numbers. So it's basically, it looks nice. It doesn't have much use. But as you can see there, yeah, it is measuring the AC cycle correctly and 50% duty cycle. So I would say we are good here. Okay, here we go with the DC current test. We're going to start off in milliamp mode, connected to milliamps, and we're going to try a few levels. We're going to start with 5 milliamps, so let's go ahead and turn this on. And it turns the lights on, and it is reading around 6.6, 6.9 milliamps. So about 2 milliamps off. All right, let's go to 10 milliamps. And it's reading at around 11.1. Okay, now it's kind of jumping around a bit. All right, let's go to 20 milliamps. A little too high there. Okay, it's reading it as 21.5, 21.9. All right, let's go to 50. Okay, and that is reading as 51.3, jumping up to 52.2 there. All right. Okay, let me turn this off real quick, and then we're going to switch over to amp mode. And let me bump this up to 100 milliamps. Yeah, this will give you an over limit at 100 milliamps, so we're going to have to switch over to amp mode. Okay, all right, here we go. Here is 100 milliamps. Nice and bright lights, and it's reading as about 102. So the general trend here is basically about 2 milliamps over. Let's take this up to 150. Okay, and we're getting 151.2, and then it jumped up to 152. So this isn't measuring quite as accurately as the Coeit's HT118A was, but it's still in the ballpark. The general trend is that it's measuring a couple milliamps too high, but it does work, and seems to be okay by me. Okay, here we go with the test of the Aneng Q10's waveform output. It's basically just a square wave ranging in various settings from 50 Hertz to 5 kilohertz. Let's go ahead and start at 50 here, and my Hantek 2C42 is calibrated. I double checked. Okay, is reading the frequency as 50 Hertz. Not a very healthy looking waveform there. Let's go up to 100, see if it gets any better. Still kind of sad looking. Frequency is holding at 100 hertz. All right, let's try 200. Starting to look a little bit better. Let's go to 300 there. Let's zoom back in on that. Its reading is 303 hertz there. Down to 300. Okay, that's starting to look a little bit better. All right, let's go up to 500. Okay, that looks okay. 500 hertz right on the nose. Let's go to 1K. Zoom back in on that. Frequency is reading at 1 kilohertz even, so that's good. Yeah, that's looking better. So the waveform looks a lot better at 1K. All right, let's go to 5K. Let's see what we get at 5. Went one too far. There we go. Let's auto back in on this. Is reading it at 5 kilohertz even. And again, 5K doesn't look too bad. There's some rough edges going on in the highs and the lows there. But overall, generally, and it's wavering a little bit, just a tiny bit. Sometimes it jumps up to 5.012 kilohertz. But for a very basic function, I would think this would be useful for something, although I would think it's meant more as a novelty than anything. But it could be useful. Okay, next up is the test with the arbitrary waveform generator. We're going to see what this Q10 can do with that. We're going to start with 1 hertz and we're going to work our way up to 5 megahertz, and we're going to be using 1 volt amplitude. This is what this is rated for. I'm not sure what the minimum is on this, but we're going to start with 1 hertz. So let's go ahead and get this rolling. Okay, all right, getting a reading there. It is reading at 1 hertz. Okay, let's go up to 10. Okay, 10 hertz right on the nose. Duty cycle looks fine. All right, let's go to 100 hertz. Okay, looking good there. All right, let's go to 1K. Looking good there. Duty cycle is holding true. All right, let's go to 10K. And looking really good there. Okay, let's go to 100. 100K. I got some jackass with one of those loud engines driving by. Okay, here's 100K. All right, duty cycle is now at 51%. Very little variation with the duty cycle so far. All right, let's go to 1 meg. Okay, 1 megahertz looks good. Duty cycle pretty much unchanged. All right, let's go ahead and take her up to 5. And we're getting 5, and it would appear that I could probably push this above 5 megahertz. Let's just do it, because I mean I'm only pushing it at 1 volt anyway. It's not going to hurt it. Okay, we get 7. We get 8. We're getting 10. All right, 11. Yep. Let's try 15. That lost it there. All right, let's go back to 11. Okay, it looks like we're losing it right somewhere between 11 and 12 megahertz, but yeah, not too bad there. It's rated for 5. It's doing 11 on 1 volt amplitude, so I'll take that. Looking good. Okay, now on to the range of tests here. For the components and stuff like that. We're going to start off with the continuity test here. We'll be using again for all these tests my probe masters. So here's the continuity test. Very reactive light. I mean, it's right with the beep. That's really good. Really good latch. I would say that's pretty fast. Okay, let's go ahead and go to, let's do some resistance. I'm going to get my resistance substitution box out for this because I want to show you another feature of the relative. The relative on this actually works up to about 100 ohms. As you can see there, this resistance substitution box, like all cheaper resistance substitution boxes, have some resistance in them. This particular one kind of wavers between about 0.25 and 0.3 ohms. So the first thing I'm going to do is rel this out. Which you just press and hold. Okay, let's do 1 ohm. Okay, getting 0.98, pretty good. Let's do 10 ohms. 9.99, again, very good. All right, let's go to 40. Okay, 40.09, pretty good. Let's try 70. Looking good there. All right, let's go up to 90. Okay, pretty good there. And then when you try this, it'll go to over limit. So we will need to take it out. And you get rid of the rel. Actually, it was measuring it there. Okay, so this is 100 ohms. Again, very good. 1K. Almost spot on there. Pretty good. 10K. 10.05, 10.04, looking really good. Okay, 100K. Nice and fast too. 100, look at that, right on the nose. Pretty good. Okay, 1 meg. All right, we're getting 10.08. Okay, let's go to 2 meg. 1.994, good. Okay, 4 meg. Okay, a little bit low, but this 4 meg resistor is a little bit low, so that's about right. All right, let's go to 10 meg. And we're getting 9.963. All right, I would say looks pretty good, pretty accurate on resistance. All right. Go ahead and go, let's see, let's do some diodes here. So let me put that in, back into that. This shares a diode and continuity, by the way. All right. I'll start off with the LEDs, I guess. Red with a reading, yellow with a reading, green with a reading, blue with a reading, white with a reading, and then the RGB, red with a reading, green with a reading, blue with a reading. Looking good there. Yeah, if I can keep my hand straight. Okay, good. All right, let's go to the diodes. First up is the rectifier. Okay, .562. Next up is the fast recovery. 5.2221. Okay, Schottky. 0.203. All right. Switching diode. .623. Okay, and the germanium. .289. So this has a tendency to do the same thing that the HT118A does. It's in the ballpark, but it does measure about 20 to 30 counts a little bit too high. All right, let's go on to capacitance. I got a couple of newcomers to the block here. First thing I'm going to try to do, well, let's get into capacitance. That would help. First thing I'm going to do, I got a little 22 picofarad in here, so let's try that. Well, 27 picofarads, not too bad. That's actually pretty good. All right, let's try, this is supposed to be 100 nanofarads, but this is really more like about 86 nanofarads. Yep, right on the money on that one. All right, let's try a few more. Let's see, we'll try, this is, I believe, a 1 microfarad. Yeah. Okay, that's pretty much in the ballpark with the others. Let's go to a 10. Okay, 10.59. Again, right in the neighborhood. Okay, let's try 100. Okay, 101.6. Again, right in the neighborhood. All right, let's go to let's try 1K here. 1,000 microfarads if I can get my leads on it. Okay, 949. Yep, 952. Again, right in the ballpark. Let's try 2200. Hopefully it'll play nice with me today. Okay. 2121. Yep, again, right on the money on that one for this one. And last but not least, the big one. This should be around 97, 9750-ish. Let's see what it does. Now if I could get it to work. There we go. $97.17. Right, yeah, right on. So looking good on capacitors, decent on diodes, excellent on LEDs, lights them all up, gives readings, and resistance is looking good, and it's handy with that rel feature there. Okay, here we go with the temperature probe test. Need to get it in the right mode. There we go. Okay. It's not that warm. Come on. All right, well, let's see. It's reacting to my hand. Yeah, it's warming up. All right, let's give it a little bit of fire. I'd say that's working. All right, looks good. I'm not sure what the temperature is in here, but when I first turned it on, okay. Cool, chill out, brother. There you go, it's starting to go down now. But I would say the thermal probe works just fine. All right, next up we're going to do let's see, what do we got next here? Oh yes, the non-contact voltage test. Let me get these out of here. See, I do not like this stand. It is just floppy and flimsy. You're going to have to be really careful with this. Okay, so we're going to test this. Let's see if I can see it. Yeah, let me zoom back out a little bit. That's as far as I can go. Okay. All right. Yeah, it sees it. All right. So here we go with the NCV test. Okay, seems to be working. Not as sensitive as the HT118A. Yeah, there we go. This one's got a nice bar meter. Yeah, it's okay. It does the job. Let's try the LED up top. Yeah, working better there. I'd say it works. It's relatively sensitive. I wouldn't call it fantastically sensitive, but yeah, gets the job done. Okay, and before we get to the pros and cons here, I never did really look at these the stock leads, so we'll do that real quick if I can get it out of the package. And your typical cheap leads, PVC. And get that off of there. They're on there pretty good. I'll do a quick continuity test with these just to show the difference. These also are kind of loose fitting. Yeah, well, actually once they go in, they're okay. All right. So let's do a continuity test real quick on these. You wanna? Any questions? Yeah, it's a great meter, but the leads that come with it, basically hot garbage. I'll never use them. Okay, and that brings me to the pros and the cons of the Aneng Q10. There's a lot to like about this little meter. Its compact size makes it convenient to carry around. This would be kind of a fancy glove compartment meter. It's got good accuracy and functionality across the board. The only real glaring exception I see to that is that the output waveform in the lower frequencies is a little bit shoddy, and that's probably being nice about it. The other thing is that it has a tendency to measure diode components a little on the high side, basically in the same neighborhood as the Kuwait's HT118A. Same deal. And as you can see here, here's a comparison between the Q10, the 2C42, and the Fluke 17B Plus on those readings, and very similar comparison to the HT118A. Again, I love the dual display with the backlight that stays on. I don't know how good this would be in daytime, but on the bench, I love it. It's great. Good build quality. I do like the finish on this. It's a little bit slippery on these black parts, but the softer plastic that they use is actually quite nice. It makes it pretty grippy. We'll get to the stand in here in a moment, but anyway, bang for the buck. Again, I paid $33 for this thing. You can currently get it around $30 to $35. Is there a market for this meter? Yeah, absolutely. I would say so. I mean, this is really up on the same levels as the HT118A models are. There's a lot to like about it. It's easy to use, and the manual is good. The little, I know I made jokes about the little tape covers at the beginning of the review, but if you're a new guy, that's probably going to help you more than it's going to annoy you. So, and finally, what I could say about the Aneng Q10 on the positive side is this is what the Aneng Q1 should have been. This, to me, just leaves me with the impression that it is a redesigned Q1 with a somewhat better display and the return of the rotary selector, which is a big fat welcome in my book. I really like it a lot. This is also related to the Aneng SZ18. It's the same exact meter, except the silk screening is different. They both come available in orange and red. The thing I don't like about the SC18 though is the silk screening and the selector dials. It's got like a dark blue, dark red, and an orange color. And to be honest, it looks kind of like a toy to me. This, I'm sorry if that makes me boring, then it does, but I just like this layout a lot better. I think it just looks good. It looks professional. Okay. Now on to the cons. The self-tapping screws in the chassis, don't really like that a whole lot. So again, I would only open it up when you have to change fuses. The continuity light, oh, that's actually a pro. I forgot about that. Continuity light is the fastest that I've got on anything that I've tried. It's a really fast continuity light, so I forgot about that. But anyway, yeah, the self-tapping screws, don't like it. It's going to drop plastic shards down into the body, and eventually if you open it up and close it too many times, you may have trouble putting it back together one day. The stand. I mean, if there's a big negative to this device, this is it. That is just absolute hot garbage. And here's the other problem. When you try to move it around, yeah, it won't take much to make it fall. And yeah, you don't want to drag it or anything. I'm just afraid I'm going to break this. So my recommendation would be treat that with kid gloves, folks. Because if you don't, you'll be sorry. The NCV sensitivity is it's okay. It's not the greatest. I mean, it does the job. They could have used a better antenna for the NCV. Again, measures a little high on diodes. Again, I've already covered that. And then the last but not least is just almost no protection. You know, basically you get one PTC, you know, a few resistors, small little ceramic fuses. There's just not much there to protect it. Definitely not meant for high voltage. And that's going to bring me to the conclusion. So, the Q10 is another really good all-around low-cost meter on the market with good accuracy and good build quality, except for the stand. It seems aimed at electronics hobbyists that are not playing with high voltage or currents. Again, could have better protection, but I definitely recommend this for hobbyists. But I don't know that I would necessarily recommend this for a novice. One reason is because even though they do introduce a little bit of, you know, countermeasures, you know, with, you know, avoiding plugging, you know, putting probes in the wrong jacks at the wrong time. The light thing on the HT118A is a little bit better safeguard. And that's why I would say, but, you know, if the novice reads the manual and pays attention to what he or she is doing, they should be fine. But once again, you know, like it a lot. I posted the link to this product is in the description below. And that's going to bring me to the end of this review. So once again, this is the ANENG Q10. Definitely gives my thumbs up. This is Sui778. Thanks for watching, and we'll see you the next time.